VLSos here. This is a video lesson on inequalities, graphing. For example, an inequality that we may start with that we want to graph could look something like x is greater than and equal to -3. This inequality has one variable, and so the graph is going to be a number line. But how do we put on the number line all of the values greater than and equal to -3? Well, let's draw a number line. This variable is solved for, meaning it's on one side of the comparison, alone and positive. If it wasn't, then we'd need to take a first step to solve for the variable in our inequality. So the process of graphing inequalities starts with a first step that we don't need to take because we've already solved. But we must remember to solve for the variable. And in the case of inequalities, move it to the left side. The variable is solved for in this example, and it's on the left. When we deal with inequalities, it's very helpful for the variable to be on the left because then the inequality symbol is very intuitive. We know that x is greater than or equal to -3. In graphing, then, we're going to go on to step number 2. Find if there is an open or closed dot. We're going to put an open or closed dot on our number line at the number on the right. The number on the right is -3. But what are we going to use, an open or a closed dot there? If the inequality symbol is less than and equal to or greater than and equal to, then we're going to use a closed dot, which looks like a point that's filled in. The reason we're going to use a closed dot is because that's the symbol for being at a location. So if we have our number line and our origin 0 is labeled, -3 is here, we're going to put a closed dot on -3 because it's possible to be at -3. We can be equal to -3. Part of the solution, part of the values that x can be, includes -3 because the symbol includes this little line at the bottom, which means also equal to. If the inequality symbol is less than or greater than, then we use an open dot. And an open dot is a symbol that suggests that it's a placeholder. It's an important location, but the dot is open, meaning it's an important location, but we can't be on it or at it. We're using a closed dot here. We'll use an open dot in another example. That was step number 2, and now to finish up, step 3. Find the direction to shade, or find which direction to shade. if our inequality symbol is greater than or equal to or just greater than, then we are going to shade up or in the positive direction, or in this case, to the right. If our inequality symbol is less than or equal to, or just strictly less than, then we shade down, which is the same thing as the negative direction, which is also to the left. Our inequality symbol is greater than or equal to. So we are going to shade up because x can be all the values above or greater than -3. And shading means that we are considering this part of the number line that we're shading to be part of the solution set. It's like we are also representing these values by shading them. This is the graph of the inequality x is greater than and equal to -3. We could also say greater than or equal to -3. It includes on the number line all the places that we shaded or put a closed dot, the -3 and everything above. Let's give another example. We'll move a little faster. This number line, by the way, was for x. Y is less than 5. We start with the number line. It'll be a number line for values of y. Step number 1, solve for the variable, move it to the left side. We have the variable solved for, it's alone and positive on one side, and it's on the left. Step number 2, find if there's an open or closed dot at the number on the right. The number on the right is 5, so let's represent 5 on our number line. We're going to put an open dot or a closed dot there. For this symbol, which is strictly less than, we use an open dot. It's a placeholder to locate an important location, but we can't be at that exact location of 5. 5 is not a solution to this inequality because 5 is not less than 5. 5 is equal to 5. Step number 3, find which direction to shade. Our inequality symbol is strictly less than, so we're going to shade down or to in the negative direction or to the left. To include in our shading all those values of y, all the possible y values that are solutions to this inequality. Last example. -1 is greater than and equal to t. We're going to have a number line. It will be the solutions for all values t that we can find. Step number 1, solve for the variable, move it to the left side. Well, the variable is lone and positive, but it's not on the left. Because it's not on the left, we might be confused with this symbol because we're going to read this symbol as greater than and equal to. But if the variable is not on the left, so we can see it as t is greater than or equal to, then we won't be able to do steps 2 and 3 correctly. So we're going to switch directions. We're going to put the t on the left. But when we do, the sign must switch to represent the inequality. These inequalities are equivalent, but t is on the left. Now when we read this inequality symbol, it's going to be t is less than and equal to -1. And that will help us choose our closed and open dots in our shading correctly. So we did step number 1. We'll locate 0 on our number line and -1. Step number 2, find if it's an open or closed dot. We're working with less than or equal to, which is this symbol. We use a closed dot because t can be equal to -1. And then the shading. The direction that we're going to shade is going to be for less than or equal to. We shade down, negative, or to the left. Just some examples and the steps involved in graphing one variable inequalities.